sure the mic test looks good. Okay, so we're going to spot drill these two holes right here. So we're going to go to drill. And then I'm going to pick the top edge of each of these holes. Make sure you don't get the quadrant point. See how that's the quadrant? The four little things on the circle there on the auto cursor? Make sure you're kind of off there to where it shows that you're getting the center point of each of these. So make sure you get the center point of those two holes. Remember, if you get one you didn't want, all you got to do is click on it again, or you can go over here and delete it out of the chart. So if I did accidentally get the quadrant point, all I got to do is click on it a second time. That unselects it. But that one, I want those two right there. Okay. All right. Next thing we're going to do, we're going to tell it OK. We're going to go to our tool list. And we're going to go select that 5/16 drill mill we created the other day. So it's at Select Library Tool, and there's a 5/16 drill mill. Make sure you get the 5/16 drill mill, not your 118-degree drill that we created last semester. Okay, make sure you get the right one, the 90-degree drill mill. Tell it OK. It should bring it in. It should make it number 4 in our tool list. Down here, we're going to tell it that we're going to spot drill. For through holes. Okay. Cut parameters. We're good here. Linking. We're going to come in here and I want you to set everything just like me right now, okay? We're going to set our clearance height at 2 inches, incremental. We're going to use clearance only at the start and end. We're going to check mark that. We're going to check mark that. That means we're going to get a G99 instead of a G98 in the code. But that means between the two holes, it's only going to go up to the R plane. For the R plane, I want you to set that at 50 thousandths incremental. Now, top of stock. We're going to do these. These are going to be absolute values, so you can set both of these to absolute. The top of stock, I'm going to click on that. We've already machined this step down to here, right? We've milled that down. So I'm going to set my top of the material right here. Should be negative 172.5. Doing okay? All right. The depth that we're going to go to, what I want you to do is set the depth right here. Set it at that same level at the top of this surface. Let's check our planes. We always want to check that, make sure they're good. Top, top, top. Work offset 0, G54. Coolant coming on after. Let's tell it OK. It's going to generate.
Your screen's not.
Oh, sorry. We're going to let it generate. Okay, so first off, the depth we set it to is right there at the surface, right? So I'm looking at that, and this is what I want you guys to get used to, okay? I want you to get used to looking at the lines and kind of being able to identify that doesn't look like it's going where I need it to. So let's go back in the parameters. And in the linking, we know we need to go deeper. We know we need to spot drill this deeper. Okay? So I'm going to use the little calculator here underneath the depth. I'm going to leave that at 172.5 and I'm going to hit the calculator here. I want to do 10 thou per side chamfer on these holes. Okay, so for the depth, it'd be the diameter of the hole, which is 266, plus 20 thou for the finished diameter, because 10 thou per side. It does the tip calculation for us. Says that we need to add 143 thou deeper to be able to achieve the chamfer after we drill the hole. We'll hit the check mark. And now we'll check out and let it regenerate. There, it's going a little deeper for us. So let's watch this. I want you to select all your tool paths. Just click on the toolpath group, select them all. And let's go to verify and let's just take a look at it. Okay. Now I'm going to do what I normally do when I get here. I turn the precision up. I usually leave the speed right in the middle where it defaults to. I turn on collision. Stop conditions, I turn on collision. When I'm working on programs of my own, if it has a collision, meaning a rapid through the part, I want it to stop right there and let me look at what operation it's doing it in. Because sometimes, this time we're going to be able to tell, but sometimes you don't know what operation causes the little issues and where it cut through the part. And I like to turn on the color loop. That way it makes each different toolpath a different color. And we'll hit play. Boom. Stops. Simulation has been paused due to the following stop conditions. A collision has occurred. The part's bleeding. You see the red, right? Well, that is in operation 6 of 6. So I know it's in toolpath 6. So that helps me kind of filter it down to what toolpath. So now I'm going to go out and look at the toolpath to then see what I need to change. Okay. I know already, obviously, because we're doing this on purpose, so you learn how to kind of approach these things. When we see red, that's a rapid move through the part. That's a no-no. There's never going to be a time where a rapid through the part's good. Okay, that's why it's red, and we call it the blood. The part's bleeding. So, I can tell you that it's because that right there, my retract's not going up high enough to basically clear this corner right here. So let's go back in the parameters and let's talk about different things we could do here. One thing we could do, we could uncheck mark this box so it goes all the way up to the initial height, then over, and then down. It's still only going to feed from 50 thou above the top of the step. So if you just uncheck that box, so now it's a G98 instead of a G99 in the code, and you hit OK, there's no more move through there. Now let's say you're on a situation where you're trying to shave every extra move and every little bit out of the program. If you go to Index and you look at some of their machines, I mean, 25 thousandths clearance is about the most they have for every movement. Like that clearance is clearance. You know, as long as it's off the part and out of the way, there's none of this 2-inch retract stuff. If that was a situation here where the rapid move is more than I want it to be, well, I can bring that clearance height down to basically wherever I want it to be without it taking out that corner of the part. Like literally, and I don't want you to do it, but I want to show you. I could bring that down to probably minus 50 thou. Oh, not. But it has to be an absolute minus 50 thou, sorry. Minus 50 thou. And if I watch this now, it's probably going to retract high enough to where it's not going to take that corner out because it's on the smaller part of the diameter of the tool. I still got it a little bit. So even 50 thou wasn't enough. But the point of this all is, at the end of the day, this stuff, these little things where we have issues with the parts and programming, we can find that right here. Okay? Mastercam, cam softwares, none of them are cheap. They all cost money. But the reason that is because there's a lot of tools in there that are going to save you money. Okay, it's not just about making the toolpath do what it's do. It's also, I mean, if that was a piece of Inconel, big old chunky Inconel, and I just ran the tool through it and scrapped the piece of material, I mean, it could be a $3,000-$4,000 piece of material that should have been avoided right here. Okay. All right. So we'll check mark out. Now let's take that same tool and let's do a contour. Let's do a contour. I'm going to set mine to solids. I'm going to have it set to the construction plane. There will not be a time this semester when you're programming parts that you won't want that to C-plane. Okay, that only time you want to go to 3D is if you're literally doing some 3D type machining with 3D geometry. We are not going to be doing that this semester. Okay, it's a summer thing, and we'll get into that. So you should always be in C-plane. It makes life a lot easier. I'm going to set it to loop right here. And then I'm going to chain this loop, but I'm going to pick it right over here on this front wall. I don't want to pick it inside the part, which is like in here. I'm going to pick it over here so that my arrow's starting right there at that branch and going clockwise. We're going to chamfer this top edge. Okay, remember, R key's reverse. F key moves it. You can move that around to different branch points. Get it right there where mine's at, and then tell it okay. Tool, still that drill mill. I'm okay with using the feeds and speeds for the drilling. Yeah, it's slower than it needs to be for this tool, and we could, but for us, it'll be okay. You know, we're not. You're going to find out that you're going to have a lot longer in setup and adjustments than what it actually takes cycle time to run this part, or 2 parts, or 3 parts, or 4 parts. Okay, it's just the cycle time's not the issue here. We're not trying to split hairs. We're going to tell it that we are going to chamfer. Edge of island, side number 1. Cut parameters. We're going to use where. And over here, I'm going to tell it to do a 2D chamfer. And I'm going to set the width at 5 thou. We're still going to do the same thing we did on the arm, where we're leaving 2.5 and 2.5 on the floor and the wall, which in a perfect mathematical world, okay, I won't say this very much more, but in a perfect mathematical world, remember, that means there really shouldn't be a chamfer, but since that tool we know has a little bit of a flat on the tip, it's going to cut a little bit. Okay, and we just want a really light chamfer. The other thing we always have to be aware of, when we're chamfering something in an edge and there's a step like we have, we got to make sure we don't have that bottom offset too deep to where it machines into that step. The step's 172.5 deep, the offset's set to 100, we got 72.5 thou clearance, so we're good. We don't have to make any changes. But there will be a time, maybe even on your wrenches, depending on how you design them. You know, I'm going to tell you to break all sharp edges. I think it even says it on the print. But you might only do like a 100 thou deep pocket. Well, if you do the pocket 100 thou deep, I probably wouldn't set that to 100 thou tip comp, because then it's probably going to drag a little bit inside the pocket. You know, I might set it at 75. I don't like to go less than 50 thou, but I will if I have to. Okay, I really don't like to go less than 50. Just because when you start getting that, as you're going up with the tip comp, it's moving the tool closer and closer to center right on the edge of the part. Depending on what the width of that web is, if you get too far up and you go right there at that same point, it'll leave a big nasty burr at the bottom of your chamfer. It's not using all just the side of the tool. It'll start kind of dragging the tip around there too. So lead in, lead out, 1025. Your 5% overlap. I shared with the gang yesterday that, you know, I know people that they've just got like a set number they put there, 20 thou all the time. They don't. I do the 0.05 times my tool diameter. Overlaps overlap. You just want something there. Typically, you're not going to want it to start and stop right in the same spot. You know, otherwise you'll have a blend line every time. Okay. Multi-pass, we can turn that off for this little chamfer. We don't need it to do multi-passes. And then the only thing we got to do is set our depths. Well, I don't really have to set anything. Mine's at 0 already, which is what that edge is at Z0. Top of stock, and the depth is 0. Master can't. The 2D chamfer contour type does all the math for us to comp over and down to cut the chamfer. Okay, we tell it the depth is where the edge is that we're chamfering. Okay. Planes, coolant, they look good. Tell it okay. Now we should be able to, since we got stock to leave on walls in there, we should be able to see it break that edge just a little bit. There it is. Looks good. Here's what I like when somebody misses a decimal place. Panic mode always sets in. Oh, hey, my chamfer's way too big. Something's wrong. Okay, that's the line that I get. My chamfer's way too big. Something's wrong. Let's go look at what size you set it at. Let's go check your depths. Those are the first places I'd start. I'd look at the size, and typically when you set it, you're going to look at it. Yeah, that's the right number, because your eyeballs, your mind's going to trick you into reading that as, you want it at 5 thou and it's 0.05. Well, I need one more 0 there, right? Okay. The things that I repeat and I talk about up here and I talk about that, it's because I see it all the time. Okay. Kind of like when we got it there the other day. We went to side 2. I had people, hey, it's giving me a travel limit situation error. I had to remind a few people. I can't remember if it was this class or Mondays, but I had to remind them, remember we use G55. You got to go in and put your offsets in G55. And I know I talked about that when we did it on the arm while we were programming it. And that's why, because I want you to get used to when you see those errors. For me, as soon as I hear that, I know we got a work offset issue. Okay, it's never that the program's traveling 18 inches from where it's supposed to be. It's because we didn't get our origin set right or in the right spot. Okay. Last thing for side 1, we're going to take toolpath 6, which was the spot drill for the through holes. We're going to copy it, make sure our red arrow is at the bottom, and we're going to paste it. We'll go into the parameters of it. For the tool, go get your letter H drill we created. There it is, 266 letter H drill. Oh man, mine didn't pull in feeds and speeds right. What'd your guys' feed rate come in as?
12.
Yours did? I just gave you my tool library. Why is yours pulling in something different? What the heck? It did? Okay. So, wait a second. Let's do this. Everybody right click over here. Hit reinitialize feeds and speeds and see if it changes. Did it change? Yours stayed 12? Okay. Everybody right click on the letter H drill up here. Edit tool. Let's go into the finalized properties, and the RPM's okay. We're using a 100 surface foot because we're setting this up for steel. The feet per tooth, let's set that at 6 thou. And then we're going to run it at 8 inches. 8 inches a minute. Not sure how that got messed up in our library, or how ours is different, considering I just gave you my file. But There we go. We're going to go 8 inches a minute, 1436 RPMs. Everybody good now? Okay. Cut parameters, peck drill cycle, it's good. Linking parameters. Our top of stock's good because it's the top of that step. But the depth, let's set that to the bottom of the step down here. So it should pull in 327.5 deep, negative 0.3275. Okay. Click on it. If you're, don't plug it in. I want you going out here and pulling it off your part. See people typing. You shouldn't be typing the numbers. You should be, click on depth, go over here and pull it off the part. Make sure it pulls in correctly. Okay. You need to get used to doing that because when you're programming on your own, I'm not going to be up here with the number on the screen for you guys. Okay. So you've got to know how to pull it in. Tip comp. We're going to click on that. I'm going to tell it to do 50 thou straight wall breakthrough. The breakthrough amount is how much straight wall, the tip plus this amount is how much I want you to break through. Check your planes, check your coolant. Everything should be good. Tell it okay. And as I'm programming, when I'm programming, after I create one, maybe two toolpaths, I'm verifying. I'm checking stuff out, making sure we're still on the right track. Okay, I'm just checking things out. Everybody look good? Okay. All right, I'm going to hide these toolpaths so I don't have to look at them. We're going to go in our levels. And I'd like you to shut everything off except for your solid. The only thing on your screen I want is your solid model. Okay. So this process that we're getting ready to do, this is how I set soft jaws up. Okay. Once you got anything else you guys are doing, let's stop right now. Okay, because you need to pay attention to this. This is something you're going to have to do multiple times. If you get out in industry, you will use this. Okay, this is alignment to fixturing and trying to figure things out. We're going to set up a soft jaw here. So the first thing I do, my first step is I set up my jaw geometry. And that first thing I got to do is we've got this top side of this part done. We got to get it flipped over, faced off, deck off the back side, and then machine the little step and then chamfer everything on the back side. That's what we've got left to do. So I got to be able to flip this part around, clamp on it, and machine the back side, right? Pretty cut and dry. But here's how I create the geometry to do that. I first decide how much of this do I want to hold on to on the back side. Well, I know I can't hold on to any more than what this step is down here because I got to be able to machine that. And most of the time, my go-to is anywhere from 125 thou, depending on how much I've got a hold of the part. You know, if I can hold on to a lot of the part, I don't need to have a real deep pocket to clamp on it in. Or, you know, if I don't have a whole lot that I'm holding on to, I might have to go a little deeper and cut my pocket a little deeper. This part, since that step's there, and I really want to make sure that I'm getting a hold of this geometry here, I'm going to just basically do half the part, which is a 1/4 inch deep. Okay, so right click with me, make sure you're in 2D, and then click on the select Z depth here. And then I just want you to pick a point right here in the middle, one of these walls right here on this step, right in the center point of it. Just click on that, and it should have set it to -250. So we've got our depth set, because now we're going to create the wireframe geometry for this. You guys good? All right. So I'm going to create a new level, and I want you to call this your soft jaw. Geometry or wireframe, whatever you want to call it, or just soft jaw. click on your part, and we're going to use that tool that we use a lot, and I use it all the time because I think it's the easiest way to do it. Bounding box. Click on bounding box. Now we've got it set to 2D, so it should just be setting a rectangle there at that plane at negative 250. Right? If you see more than that, you probably didn't set it to 2D. And you need to go do that. Now, here's how big I want it to be, because it's not really the size of this part now. What we're drawing is what you would see if you were looking over the top of the vice jaw, what the object line would look like for the vice jaw. Our jaws are 6 1/4 wide by 1 inch thick. Okay, 6 1/4 by 1 inch. So we're going to create that rectangle right there. Okay. Make sure it's set to create lines and arcs, and then hit OK. So, step 2, we got to figure out how much we want the jaws open. So anytime we use soft jaws, you got to have clamping force. We can't take the jaws and close the vise all the way up, and then cut a pocket into the jaw, open it up, put our part in that pocket, and then close the jaws all the way up and think that there's going to be any clamping force. Because the jaw's clamping force is up against the other jaw, right? So we got to space that a little bit. I try to keep it as minimal as possible based on the part size. Now it could be, if I've got a wider part that I'm holding on to, if I'm holding on to this indicator here, that's how we do side 2 of this. We cut a jaw this shape and we hold it. If I'm holding on to this, yeah, I might have an inch gap between the jaws. I'll put a parallel in there down in the bed of the vise. I'll close it on the parallel to hold it tight, and then I'll cut the pocket for the shape of the part. It's a little part. Okay, minimal. So here's what I want you to do for me. Select that geometry, go to transform translate, go to the translate up here. We're going to do a move. Okay, and we're going to move it in Y half the width, so 0.5. And I want you to set that to both sides down here. Both sides. All right. Huh? Got it? Translate. We're doing a move. We're going in both directions. And we're 0.5. And if you look at that in your top view right now, I want you to think of that as the vice jaws are all the way closed right now. Okay, that's what we're looking at. That's the vice jaws all the way closed. But I need to put a little space in there and clamp on something to hold that space so I can cut the pocket that's the shape of my part for my part to sit down in and hold on to it. The easiest thing you've got out there is your parallels. All right? The parallels are an 1/8 inch thick. Okay, they're an 1/8 inch thick, which is a small amount, but it's enough. So when we cut this soft jaw out there, we're just going to take our shortest parallel, we're going to stand it up in the bed of the vise, and we're going to close the vise on that parallel. And that's going to hold that 1/8 inch gap while we cut the pocket. So what I need you to do here is add to the Y here, we're going to add a 1/16. Why a 1/16? Because it's moving it both directions. And that just opened our vise up to an 1/8 inch gap. Okay, that's our 1/8 inch gap. We'll tell it OK. Right click and clear colors. All right. We have created the wireframe that we need to create our plane for side 2 now. Okay. So everybody go to the top view, kind of draw into your window so you're looking at it like me. Alt 1, Alt F1, Alt F2. Okay, that'll put you in the same orientation as what I am right now. Let's all make sure that yours looks just like mine. Yes, sir. On side one right now, we're going to rotate this around. So what I want you to do is just take your mouse and spin this part around to where it looks like this right here. We're spinning it to the other side. Okay. This is going to be our origin for this plane right here. The left front top corner of the fixed jaw. This is the origin for side 2. I'm going to say this multiple times and I'm going to repeat it. This is the origin for side 2. Once you edge find the jaw in X and Y and you set your Z off the top of the jaw, that's your side 2 origin. Even for cutting the part. It's all going to be based off that origin that we set on the jaw. What everybody wants to do is cut the jaw pocket and then put the part in the jaw and then come over and edge find on their saw cut of what's left to deck off and set their Z off the top of the part and then want to know why the part, everything's happening up over here. Okay? There's a good fixture back here. The cam system gives us the ability to put the origin wherever we want it and not have to worry about edge finding on the part. Okay? This fixture is 3D modeled. Okay, it's obviously we 3D modeled it in Mastercam. This is basically a 1, 2, 3, 4, 5, a 5-station fixture that takes a piece of material that looks just like this. Now it doesn't have those holes yet because those holes they get created back here. But it takes a piece of material and it creates the skateboard truck that's up there on the top shelf. All in a 3-axis machine. It does all of the different orientations. The origin for this program, you guys see this little steel bushing right here? The center of that is your X and Y origin, and the top of this plate right here is the Z. And everything in Mastercam is programmed from that spot, one offset. And then everything else is all based off that. Okay? So the origin's here, but the part, there's multiple parts going through different stations because it doesn't have to be off the part all the time. As long as we position it in the graphics where it's going to be positioned back in reference to that origin at the machine. Does that make a little more sense? Yeah.
Does that do all 5 operations in one setup?
Yes.
Like you can do
So you,
one run?
yeah, you hit one run, the part, every time you take a finished part out, you load a new piece of stock here, that stock goes to here, then it goes to here, then it goes to here, and then it finishes right here. So it doesn't finish 5 parts, but it does one of the other opposite orientations for the parts. So what that was they gave us a challenge, said, hey, you've got a 3-axis machine, you got to make this part. We're going to give you all this Mighty Byte fixturing. So if you want to build a fixture to do it, you can. Or if you want to just do multiple setups, you can. It's kind of a funny story. We went to Philadelphia for a competition 2013 with Mastercam. There was like 3 teams from China, 6 teams from the United States, 2 were educational, a couple were Mastercam resellers, and it was like a cohort that we came in there and all worked together. We were the only ones that showed up with a purpose-built fixture for the project. Everybody else showed up to like do it on site. We showed up, we were ready to go. Like we'd already ran parts. We made sure the program worked. We made sure the fixture worked. So, needless to say, we made a pretty good impression with the group. But I always go back to this thing where, you know, we got to work smarter. That's how we get jobs back from China, and we keep reshoring these jobs. We can't work as hard as they are. And it was crazy. There was 6 of us total. 2 of us were instructors, and me and Mr. Bauer sat back and didn't do anything. The 4 students that were with us ran the show. One of the teams from China had 19 people on it. One of the other teams from China had 13. Okay. They'll throw a ton of labor at it, and there's one person deburring parts, there's one person doing this. We had 4 guys. doing the work of what they were doing with 19, and more efficiently, because they were, when they saw that we had built that fixture here in house and brought it along with us. You know, it was a way to take a 3-axis capable machine. We didn't have a multi-axis, and create a finished part without having to open the door. Every time once the part got through all 5 stations, another part was following up and would cycle out. So, all right, let's get back to this. I'm going to go to my View tab and go to Show Axis. I'm going to shut the world off. Okay, I'm going to shut the world off. That way it isn't there when we create our new one. And then let's go to our planes. I want to create a new plane by geometry. New plane from geometry. That means we're going to use wireframe to create it. So, when we do this, we are going to click the X first and the Y second of where we want the origin at. If you do that, you don't have to sit there and click through and try to get the Z and everything going in the right direction, or have to go in and edit the spin circle to do it. So like right here, I want this to be my X axis, and this is going to be my Y right here. And then you notice it defaults to the orientation I want. Always be thinking of that right hand rule. That's the orientation I want. My Z's going up, my Y's going away from me, my X is going to the left or the right. I'll tell it okay. From geometry. Side number 2, soft jaw origin. That's what I want you to make that. Side number 2, soft jaw origin. For the offset, I want you to hit manual here and hit get unique. It should automatically pick up 1, which means this side's going to be G55. This side's going to be G55. So if we were making these parts and I had to make bunches and bunches and bunches of these, one thing I would do first off is I'd utilize my vise more. So I'd probably be making 3 side 1s in one vise, you know, with a little stop for each one of them. And then in the second vise, I'd have 3 of the pockets we're getting ready to cut in the second vise, so I can take them from vise 1 to vise 2, and then if I had bigger than a machine, I'd have a vise 3 to do the third side ops, which is to bore that bore in the end of the part. We're only making 1 at a time, so we don't have to get that crazy, but vise 1 would be G54, vise 2 would be G55, and vise 3 would be G56. And that's where the work offsets would progress, all in the same machine setup. Make sure you got it to set your WCS tool plane and construction plane, make those active, and hit OK. Alright guys, that's our origin for this side 2. We're going to cut the pocket, and we're going to cut the pocket, and we're going to do the side 2 operations with that as our origin. Okay. All right. Everybody's good? Okay. Let's go to levels. I want you to make a new level. Call this one your soft jaw pocket. Okay. What I'd like you to do is set the Z depth at the bottom of the part down here. What do you notice? It stayed the same. So what I just did was verified. I'm going to hold on to 1/4 inch of the part, because we're going to cut a pocket 1/4 inch deep in the jaws to slide this part down into. Okay. Why is this thing on this zoom thing? I'm not sure why it keeps doing that. All right. Next thing I'm going to do is I want to create a profile of the part. What's the easiest way to create the profile? Silhouette boundary. So I'm going to select the part. I'm I'm going to click on the silhouette boundary in the shapes menu. Make sure it's set to arc fit, and then I'm going to hit OK. Then I'm going to hide the solid, and I'm going to hide the soft jaw geometry. I just want to see this on your screens. Okay. All right. Soft jaws. This is a pair of hard jaws. We cut these purposely, or actually I didn't. These got cut. This was literally a pair of jaws got handed to me when I got soft jaws introduced to me. Whenever I was sitting where you guys are. Okay, these have been around for a while. But these are a good example of kind of explaining how soft jaws work. Soft jaws will locate the part left and right, forward and backwards, up and down, in Z based on the depth of your pocket. It kind of helps hold everything. What you have to be careful of is undercuts, because you have to be able to open and close the jaw. So if the part's got what I would consider an undercut, which is like this here, kind of cutting back in and then coming back out, we got to do some work on that. Okay? We got to do a little work on that. This is a good example of it. If these were in the vise, you wouldn't be able to open the vise. Like right now you can because everything's real loose, but you wouldn't be able to open the vise because it has an undercut here that they machine back into it, and it's locked. The part's locked in there. We don't want it to be locked in there. Pass those around. Don't drop them on your toes. They're not soft jaws. They're steel jaws. Yeah.
So if you get locked, what would you do?
You need to fix your pocket. You don't. If they get locked, you got to fix what you did wrong. It's not a thing that happens. You can't really use them. So up here, while those are going around, we're going to take these two circles here because we don't need them. I'm just going to hold shift and delete those out. And now that we've got the part profile, we're going to create, clearances and stuff that we need. So the first thing I want you to do, okay, I need you guys all kind of don't get too crazy on those soft jaws so you're not keeping up with us. First thing I want you to do is, this right here is a problem, this undercut, this kind of back cut. It doesn't have to be the exact shape of the part, it just has to have enough of the shape of the part to hold on to it and locate it. So what I'm going to do is I'm going to draw a line. I'm going to create a line endpoints that goes tangent from this arc to this arc. So I'm going to create a tangent line from this arc to this arc. Make sure tangent. Don't let it snap to the quadrant point up here. Make sure it's going tangent. And then tell it OK. And then, once you've created that line, I want you to trim out all of this in here. Okay, trim all that out. Make sure you don't leave any little hangers in there. Make sure you clean it all out so it's a good solid loop. If you get something you didn't mean to, Control Z, but let's trim that out so that it looks just like this. That'll take care of our undercuts, our back. I keep calling undercuts, but it's like where it cuts back into itself and then comes back out. We don't want that in soft jaw pockets. We're okay. Like I said, it's still going to locate the part. It's still got all of this around here. It's still got this arc over here. Okay, it's still going to open and close and locate the part. That's all we care about. It's still going to hold it just fine. Then the next thing I do is I got to start thinking about, okay, what tool am I going to cut this pocket with? Well, we're going to use our 1/4" end mill. So then I got to look at things like, all right, what's this radius? Well, that one's plenty big. It's 1/2 inch, but what about these little guys? Oh man, those are 63 thou. Okay, well, my 1/4" end mill can't machine that, can it? We're cutting on the inside of this. It can't machine that. So we're going to do a clearance fillet, which is similar to what you're doing on your wrenches when you cut the hexes. Okay, that clearance fillet is this how you create them. So we're going to go up to the fillet menu. We're going to select fillet. I want you to set it to clearance fillet. We're going to do an extra 10th thou here. And the radius just needs to be bigger than what our tool radius is. Typically, I add 25 thou to the radius. That's kind of my go-to number. So if 125 is our tool radius, I'd put 150 there. Now, I got to do that from this wall to this wall. There we go. And I got to do one from here to here. Now, if I didn't like that, if I was in panic mode and I was like, man, that didn't leave much flat there, my only other option is do a smaller clearance fillet using a smaller tool to cut the pocket, but I don't need to. This little flat right here, it'll hold that part in there for us. You know, it's still got, we're clamping over here. This is really just keeping the part from moving to the left. This flat face here, and then all of this up here is really what's pinching the part. What's on the left and right is really just helping keep it centered where it needs to be. Okay. No two people typically. You know, you guys will do a lot of soft jaws to start out, probably really similar to what I do because that's what you know right now. But you're going to get to the point where I could give 6 of you in this room the same part, and how you hold on to it on side 2 may not be the exact same. Most likely will not be the same. Okay, it's just that this isn't the only way I could hold this part. You know, I could have this part spun and hold it. I could just be holding on to the island. You know, I could be getting kind of crazy where we just got a pocket where the island sits down and the step sits flat, and it's just holding on to the island. You know, it's just whatever works best or whatever makes most sense to you. This is just how we do this one. Okay. So we're all clearanced out. You can see there, like I said, it's going to locate off this. That's holding against this wall. We got all of this arc up through here and this straight wall here, and then even a little bit on the front side of this that's clamping. And then we've got this down here and the arc over here that's helping keep us centered up. It's making sense? Okay. All right. So, let's go to our tool paths. Yep.
I got rid of that.
Yeah, that's what I'm hoping.
You don't get a hit, do you?
No. All right, we're going to create a new toolpath group. So we need to right-click the sweep it knuckle. The machine group, remember, right-click the machine group up here. Go to groups, new toolpath group. I want you to look at it right now and make sure it's in the right spot. If it's not, I want your hand up. Everybody good? It should be, the line from side 1 should go straight down to toolpath group 2, which is going to be soft jaw. Side number 2. Okay. We good? All right. We're gonna make sure your red arrow's in the new group 2. Make sure in your planes, make sure your new plane is your active plane. What do we do if it's not? We click on it, we hit the red equal sign. We make sure that's our active plane. Yeah.
Well, my plane's, it's the check marks on the top plane, and then offsets is 0.
That's fine. All we care about is this right here. WCSC plane T. Make sure that's all there. Top plane's got a check mark because it's being used. They'll always have a blue check mark if they're being used. Okay? This plane was used to create that new origin. Toolpaths. We're going to create a regular pocket toolpath. chain this pocket right here. Good. Tell it okay. We're going to use our 1/4 inch end mill, tool 3, and we're going to say cut soft jaw pocket for part. Cut parameters. We're going to do a standard pocket, stock to leave, 1% of our tool. On the floor and the walls. The depth and the size of the pocket's important because it's what locates the part. We need to hit these numbers. I get asked a lot, like with a pocket like this, well, how do we really measure that? Well, hopefully, before you go cutting your soft jaw pockets, you've already cut side 1 and got it on size. Because how many here have used a go, no-go before? Okay, does everybody know what the concept is? Go, no-go? It either goes or it doesn't go. When it won't go, we're not there yet. And once it goes, we're there. Okay? We want it to fit in the pocket. So what you will do is it will start out small. We'll leave in stock. You're gonna comp it a thou. You're gonna cut the pocket again. You're gonna take your part, which is the positive of the part, and you're gonna stick it in the pocket, which is the negative of the part. You're gonna see if it'll fit. If it doesn't go, you're gonna go another thou. And you just keep doing that until you get your soft jaw where it needs to be to hold on to your part. Once it just slides in ever so slightly, it doesn't have to be tight. You know, we're not splitting the atom here. Once it goes in, you're good. Your depth has to be the 1/4 inch deep because we're going to be holding on to a 1/4 inch of the part. We got to get the overall part to 1/2 inch thick, which means that there better be a 1/4 inch sticking out of the top of the vice jaw. If you don't cut the pocket deep enough, then the part's sticking up higher than it should, and if you deck it off and you measure it a 1/4 inch, and then you take it out and measure it, it's probably going to be undersized. Or if you cut the pocket way too deep, you're going to face it off and probably freak out when you do it because then you're going to measure it and it's going to be like 200,000 sticking out because you cut your pocket 50 thou too deep. Okay, so this stuff all correlates. It's what's locating the part. Roughing, we're going to do a morph spiral. Entry motion, we're just going to set that, the minimum here, at 10 and 45 maximum. Okay. Set the plunge angle at 1.5. Finishing, make sure that's set to the finish pass and then just set it to where. I'm not worried about slowing the feed rate and spindle speed down on a soft jaw pocket. We'll just leave it at its actual calculated rate. I am going to say machine finish pass only at the final depth. Lead in, lead out. I'm going to do my 10 and 25. With my 5% overlap. Okay. We don't need depth cuts for this. We're going to cut it. And then we'll measure our depth and we'll make the adjustment and get it to depth. We're only cutting it once, or well, twice after we make our adjustment. But we don't need depth cuts for this. We don't want breakthrough. Linking parameters. We're going to turn that on. Okay. The top of stock's where? Where's the top of the stock? Top of the jaw, right? So it should be Z0. And then the depth that we're machining down into the jaw should be 1/4 inch deep. Okay, so the top of stock's the top of the jaw, which is the origin, and I've got the stock shut off, or the wireframe, but I can still click the origin right here. And the depth's going to be down here where we're machining the pocket to. Planes, coolant. If everything looks good, we'll check mark and look at what we got. We're not quite there yet. Who can tell me what they think we should fix on that toolpath? It doesn't. Pocket doesn't matter. Pocket doesn't matter. A good practice would be to always do it counterclockwise. And I clicked it the right way, but it's cutting on the right side though, and it's climb milling. But what else do you see there when you look at that? Anybody? How about this? That it's helixing down and then it's kind of moving over into the cut. I want to center. I want my entry motion. I always want it centered on where the start of the cut is. So what I want you to do is, in wireframe, with this toolpath turned on, go to create point position right here. Put one somewhere in the middle, right there. Just put it in the middle of that first helix out. Okay. And go into the parameters of the toolpath. First thing we need to do is we need to go add that point. So we're going to go to toolpath type. We're going to click right here, select chains. Right click, add. And then pick that point. And tell it okay.
How did you determine the point?
Huh?
How did you determine?
I just put it in the middle. Right here. Of the toolpath. Clicked on center on entry point. We chain that center point and let it regenerate. Everybody good? Okay. Yep. No, it's the green's where it's helixing. It's helixing down, then it's moving to the inside of it, and it's that in there is already out. Yeah. Okay. We good? Yeah, anything? Okay. All right. What I want you to do next is go to your levels, turn your solid back on, turn your stock wireframe back on, and shut your soft jaw pocket off. We're done with that. Okay. I'm going to do 3 of these toolpaths with you. Or actually, I'm only going to do 2 of them with you. And then you're going to do 3 of them. Okay. So you need to really pay attention and focus on the process. And if you don't, You'll have to go back and watch the video. Okay. All right. Right-click the machine group name again. Right-click up here the machine group name and new group, new toolpath group. This one's going to be side 2. Sweep it. Knuckle. All right. Every toolpath for side 2 can be pulled out of side 1 because we're basically taking and mirroring everything we did. All we got to do is kind of what we did on the arm. Copy it, change the plane, reselect our geometry, change our linking parameters. Okay, same thing we did on the arm. So, first thing I'm going to do is face the back side. So I'm going to take the facing from side 1, I'm going to copy that and paste it down here. Make sure your red arrow's in your new toolpath group and just copy the facing toolpath and paste it down here. And then let's go into the parameters of it. First thing we change is, what's the first thing we change? Huh? The planes. First thing you do when you copy from one plane to another, you change the planes. Okay, let's all say that together. The first thing we do when we copy from one plane to another, we change the planes to the new plane. That's the first thing. If you start selecting geometry and linking parameters and all that stuff and then change the plane, all that stuff's wrong. Because once you change the plane, then it mirrors it all. And we'll throw it all off. So the first thing we're going to do is change the planes to the side 2. And it's got to be matching planes across the board. Okay. Coolant. Looks good. We'll go back up to toolpath. In the facing, there is no chain geometry. Alright. So we're good there. It's using the stock setup, right? Okay. Tool. All we gotta do is say we're gonna face side 2. To thickness. Now I'm going to stress this. I can lead you guys to water and tell you all the things I need to tell you to try to not mess up your parts. Once you cut your pocket, even if you get it right at 250 deep, I still want you to add 15th out of the Z before you go facing off side 2. That way you've got some extra meat on the bone to comp the work offset down to get your part to thickness. Okay, don't take the chance at being oversized. Just everything you can do to make sure you dial it in. Cut parameters. Nothing needs to change here. All of this is good. We are going to turn on depth cuts. And we're going to tell it to do one finish cut. 10th thou deep. Now this tool, this inserted tool, the speeds and feeds, it's going to get a really good finish. So we're not even going to slow down the feed and speeds for the finish cut. It'll give you a good finish with this inserted tool. Everybody good? Okay. Linking, top of stock. Where's the top of stock at now? Not top. The vice jaws aren't. This part's sticking up out of the vice jaw. It's the top of this box right here. So 0.5. And we're facing it to the depth of the part right here. 0.25. We've got about a 1/4 inch to face off that backside. If we took 10, 20 thou off the other side, maybe we got a little bit less, but theoretically, perfect math, we've got a 1/4 inch to face off there. Planes, coolant, tell it okay. Everybody's look good? All right, now, here's what you guys are going to do, and I know you will. So I'm going to do it. Select the machine group. So we got all of our toolpaths picked, and let's verify it. Let's see what the part looks like. Now that we got the side 2 facing on there. What's the problem? Okay. Here's what you guys will do. You'll go select it, and then you'll freak out. My whole part's gone. Okay, I say these things like this because I've been through this so many times, and I see people do it. Hey, something's wrong with my program. My whole part's gone. Because they're selecting their soft jaw pocket to verify their part. And that soft jaw pocket can't be selected to verify the part. So you got to be careful that you're just selecting side 1, hold control and select side 1 and side 2. Select side 1, select side 2, then verify it, and you should see a little better result. Face it off, there we go. That's where we're at. Okay? No reason for panic. Just got to make sure you select the right stuff. Okay? All right. We all good? You guys good? No, you can't hit shift. You got to hold control and click on the toolpath group. If you hit shift, it's going to try to select the one in between them. You got to hold control and pick the 2 that you want. If you hit shift, it'll do this. It's going to grab all of them. Okay. All right. Last toolpath I'm going to show you, and then you're going to do the last 3 yourself. We're going to do we need this toolpath? We've already roughed the outside, right? We've already got the whole outside profile is to size. We did that on side 1. Talked about that the other day. Anytime we can do that, we're going to do it. Do we need this toolpath to rough the step on this side? Yes, we do. Yes, we do. So toolpath 3 is the next one we're going to copy. Because I need to rough the step on this side. We're going to go into parameters. Okay. What's the first thing I'm going to change? Hey, that's better. We're going to change the planes. Soft jaw, soft jaw, soft jaw, side 2. Everybody good? After the planes, the geometry. So we'll go to toolpath type, which is where the geometry chaining's at. I'm gonna just hit remove change from the other side. I'm gonna hit remove chains. Down here I'm gonna hit remove the avoidance chains. I want the stuff that represents this side of the part. For the machining region, we want to machine, and you'll have to go to solids. And then I would put it on solid loop so that that's what's selected. We want to machine this area right here. So that's what I'm going to pick for my machining region. And I want to avoid the island up here. Okay. Cut parameters. Should be good. We're doing the same stock to leave and everything. The tool, I guess we could have make sure our comment rough step side 2. But everything there is going to stay the same. You know, if it worked on side 1, why wouldn't it work on side 2? Entry motion, we're doing from the outside on this, so it's going to plunge off the part. So it doesn't matter what I put here, it's going to plunge off the part. The only thing I got to set is the top of stock to the top of the part right here, and the depth to the top of the island down here. So 1/4 inch top of stock, and then we're cutting this step down to 77.5 thou. And if you do the math there, there's 172.5 thousandths between those two numbers, because that's the depth there. Check your planes, make sure it shouldn't have changed. We just set it right. Your coolant should be good. Hit OK. All right. I'm going to tell you what the last 3 are that you need. Did everybody get that okay? That rough step? Okay. The next 3 you're going to do: the finish the wall, which is toolpath 5. The spot drill, which you're going to come in and chamfer 10 thou chamfer on this side. These through holes are already there. We don't have to re-drill them. We already drilled them all the way through. But we are going to hit this side and put a chamfer on it. And 5, 6, and 7, basically. The chamfer on this top edge. So you're going to copy. You can do them one at a time. You can copy all 3 of them and just modify one at a time. But you're going to take 5, 6, and 7. You're going to paste them down here. You're going to copy, paste, and modify. Okay? 6 is the spot drill to chamfer the holes. Go look and see what it did on the other side, and that'll tell you. Okay? You might have to create a curve on the edge, or you could take your curve from the other side and make a copy of it, translate a copy of it to this edge. I don't really care how you do it, as long as you know to do it. There's what it should look like.